if the index of refraction of water is 4/3 and the velocity of light in air 3 into 10 to the power 8 meters per second, then the velocity of light in water is equal to. We know that refractive index N equals C over V. C means speed of light in vacuum or air medium. We can consider air as vacuum because of we are considering refractive index of air equal to refractive index of vacuum. Now, refractive index of water is given as 4/3 and speed of light in air 3 into 10 to the power 8. We have to find the velocity of sound wave in water. It is V. Then we can simplify it. V equals 3 into 3 into 10 to the power 8 divided by 4. 3 into 3, 9 divided by 4. 9 divided by 4, 2. 1 remaining. 10 divided by 4, 2. 2 remaining. 20 divided by 4, 5. 2.25 into 10 to the power 8 meters per second. Then answer is one. The figure shows a ray of light passing through a block of glass having a spherical air cavity. The path of light ray in the cavity is best represented by the ray. We have to select the correct ray. Now, this is the cavity. Outer medium is glass. This medium is air. Inner medium air. They have given a ray like this. We know that perpendicular line drawn to the spherical surface should be radius. Then this one is the perpendicular line, dotted line. And this outer medium is denser medium. And inner medium is rare medium. When the light ray is moving from denser medium to rare medium, it should move from the perpendicular line. Therefore, it should move in this direction. There is only one ray drawn to the correct direction. It is E. Then answer is 5. When the light wave traveling in a rare medium enters the denser medium, we have to select the correct statement. They have given about velocity, frequency and wavelength. I will explain it. We can use V equals S lambda to explain it. They have given that the light ray is traveling rare medium to denser medium. Then velocity of light ray should be decreased from rare to denser. At the denser medium, velocity is a value less than rare medium. But we have to remember, frequency of any wave is depending only on source. It means generation of wave. For an any type, frequency is depending only on source. It is not changing when refracting, reflecting or any other situation. It is constant for the wave. Therefore, according to this equation, when V is decreasing, lambda also decreasing. Therefore, we can get fourth answer as the correct answer. Both velocity and wavelength change. I have get that velocity is decreasing at the denser medium. It is valid only for waves which are moving with the support of, without the support of medium. We know that light is traveling without the support of medium. It is traveling through the vacuum. Therefore, velocity decreases when medium is denser than previous medium. Which one of the following summarize the change occur when visible light passes from air to gas? Same theory. Air to gas. Then relative to light rays, air medium is rare. Gas medium is denser. Because of velocity of light ray in gas is less than velocity of light ray in air. According to V equals F lambda, when velocity decreases, lambda is decreasing. Therefore, lambda wavelength in gas should be less than wavelength in air medium. But frequency is not changing, it is depending only on source. Then frequency not change, no change, speed and wavelength change. Then answer is 5 for the question. 5. A beaker contains 2 immersible transparent liquids A. Liquids A of different refractive indices A and Na and Nb. They have given that Na is greater than Nb. It means A is the denser medium, B is the rare medium. If a rod sits into the liquid and viewed from the top, it will appear as. Then we have to consider real depth and apparent depth. If there is no any liquid in the beaker, the rod should be like this. And when considering apparent depth, we know that the medium, outer medium is air. Therefore, we can see the rod from air. Now, we can see this point as a point like this because of this A medium. In A is greater than outer medium. Outer medium is air. Its refractive index is 1. Therefore, we can see an apparent distance which is less than real depth. Then, when considering this point, it is in second medium. Now this medium is B. In B is the small, MB is less than NA. But it is greater than outer medium. Outer medium means air. Then the second medium is A. They have given that in A is greater than NB. Therefore, apparent displacement of this point should be greater than this apparent displacement. Then it should be like this. It means we can observe the rod like this. We can get roughly the rod should be like this. Then answer should be 1 for the question. A ray of red light AO traveling in glass medium is incident on glass air interface XX dash at an angle of incident alpha as shown in the figure, where alpha is the critical angle of glass air interface for yellow light. The possible subsequent path or paths of the red ray is OR. First of all, we have to compare critical angle of red light and yellow light. I will get colors of visible range: red, orange, yellow, green, blue, indigo, violet. We have to remember that velocity of red color is the maximum velocity we can observe when comparing velocities of these 7 colors. Then we can consider refractive index. Refractive index is C over V. C is velocity of light in vacuum. It is constant for all colors. And when increasing velocity, refractive index is decreasing. There is a inversely proportional relationship between velocity and refractive index. Then we can get refractive index of red color is less than refractive index of yellow color. Now I will write the relationship for critical angle. N equals 1 over sin C. C is the critical angle, not this C. It is velocity of light in vacuum. This is critical angle, C. Then considering this relationship, N and sin C are inversely proportional. Therefore, when decreasing refractive index, sin C is increasing. It means critical angle is increasing. Therefore, critical angle for red color should be greater than critical angle of yellow color. They have given critical angle for yellow color is alpha given in the question. Then critical angle of red color is greater than alpha. It means incident angle for this given ray is less than critical angle. Therefore, we can't see total internal reflection. The light ray should pass to the second medium. When passing, we know that this is the denser medium, this is the rare medium, because of they have given glass air interface. This medium is glass, this medium is air. Therefore, glass medium is the rare, denser medium, air medium is the rare medium. Therefore, the ray should be deflected from the perpendicular line. And we know that when a light ray passing through two transparent mediums, there is a partial reflection. It means about 10% of light rays should move in this path. It is like reflection, but not full energy. If the energy of this wave is 100%, we can observe that about 10%, not accurate value, approximately, about 10% moving through the same medium according to laws of reflection. This angle should be equal to this angle. It is partial reflection. Then this ray is the partial reflected ray, and this ray is the refracted ray. Energy of refracted ray should be about 90%. Then we can get the answer. Path should be OC and OE. OC and OE. Then answer is 5. A ray of light traveling through a medium of refractive index N1 has a speed V1 and wavelength lambda 1. If the ray then enters the second medium of refractive index N2, which of the following correctly gives the speed and wavelength of the ray in the second medium? For the first medium, refractive index N1. For the second medium, refractive index N2. The speed of first medium V1, we have to find V2 value, velocity of second medium. They have given wavelength for the first medium lambda 1. We have to find lambda 2 value. We can write for the first medium, refractive index is C over V1. Velocity of light in vacuum divided by velocity of light in corresponding medium. For the second medium, we can write N2 equals C over V2. Then we can divide these two equations. N1 divided by N2 equals C over V1. When dividing by this term, we can multiply by the reciprocal. Then we can cancel out C and C. Then V2 should be V1 N1 over N2. This is the velocity at second medium. Now we can use for the second V equals F lambda for both mediums. In the first medium, V1 equals F lambda 1. For the second medium, V2 equals F lambda 2. I have used same F value because of F is not changing. When passing through the medium, it is depending on source. Then we can divide these two equations. V1 over V2 equals F is cancelling lambda 1 over lambda 2. We know that V1 over V2 ratio should be equal to N2 over N1 ratio. We have to get V1 over V2. V1 over V2 equals N2 over N1. Then we can get N2 over N1 equals lambda 1 over lambda 2. Then we can subject lambda 2. Lambda 2 equals N2 over N1. No. Lambda 1 into N1 over N2. Then third answer is the correct answer. The person who is at a riverbed look upward through the water surface of the river as shown in the figure. The person's eye is located at P and water is clear and still. Which of the following diagram best represents the view seen by the person? We have to consider light rays given in the question. they have given a light ray like this. I is at this place, observation point of observation, and a light ray like this. Therefore, he can see bottom of tree and leg of man. Then I will consider a light ray coming from head of the man. We know that this incident angle should be less than incident angle of the ray given from leg. Therefore, this ray is refracting at this point. The ray is coming in the right hand direction. Therefore, he can see the man like this. By using the same method, we can get that he can see the tree like this. Therefore, answer should be 1. He can see full image of man and tree because of they have given a light ray corresponding to bottom of both objects. The answer is 1 for the a light wave of wavelength 450 traveling with speed 3 into 10 to the power 8 meters per second in a certain medium enters another medium of refractive index 1.5 times that of the first medium. The speed v and wavelength is the second medium. We can use n equals c over v. For the first medium, I will consider refractive index as n c over velocity is given as 3 into 10 to the power 8. For the second medium, they have given refractive index is 1.5 times that of first medium. It means 1.5 n. I will use it c over 2n. C is constant, we have to find velocity. Then we can divide both the equations. C is cancelling, n is cancelling. 2 over 3 equals v over 3 into 10 to the power 8. Then velocity of wave in second medium 2 into 10 to the power 8 meters per second. Then we have to find wavelength. We can use for the first medium v equals s lambda. Velocity 3 into 10 to the power 8, frequency f. Wavelength for the first medium is given as 450. Then for the second medium, velocity is found as 2 into 10 to the power 8. Frequency f, it is constant. It is depending only on source. We have to find wavelength lambda. Then we can divide two equations. We can cancel out common terms. Then lambda equals 300 nanometers. 2 into 10 to the power 8 and 300. Then answer is 3. A ray of monochromatic light traveling in air is incident on a layer of water which is presented on the surface of glass block G. Which of the following ray diagrams correctly represent the subsequent path of the ray? It is coming from air to water. We know that water is the denser medium, therefore it should deflect towards the perpendicular line. Then when considering water-glass interface, refractive index of water is 4/3. It means approximately 1.3. Refractive index of glass is 1.5. Then again it is moving towards the perpendicular line. Then answer should be 5 for the question.